The global next-generation firewall market exceeded $5.4 billion in 2025, which is a lot of money spent on something most people think is just a checkbox in their router settings. But firewalls have evolved from simple traffic cops into full-blown security platforms that can think, analyze, and block threats in real time. So let's go through every type and figure out what each one actually does. Packet filtering firewall. This is where it all started. A packet filtering firewall looks at every data packet trying to enter or leave your network and checks exactly three things: the source IP address, the destination IP address, and the port number. That's it. If the packet matches a rule you've set, it passes. If it doesn't, it gets dropped. Think of it as a bouncer who only checks your ID and doesn't care what you're carrying in your bag. The problem is obvious. A malicious file can waltz right through as long as it comes from an allowed IP address on an allowed port. Packet filtering is the cheapest, fastest, and most useless firewall type for modern threats. It exists in every router on Earth, and it protects you from approximately nothing sophisticated. Stateful inspection firewall. This was the big upgrade. Instead of looking at each packet individually, a stateful firewall remembers the state of every active connection. You requested a web page? The firewall remembers you started that conversation. When the response comes back, it lets it through because it's part of a legitimate session. But if a random packet shows up claiming to be a response to something you never asked for, it gets blocked immediately. The metaphor is perfect. The guard remembers that you ordered a pizza, so when the delivery driver shows up 30 minutes later, he gets let in. But a stranger claiming to have pizza you never ordered gets turned away. Stateful inspection was the gold standard for years. The problem is that it still only operates at layers 3 and 4 of the OSI model, which means it can see where traffic is going, but not what's inside. And in 2026, the threats are inside the packets. Circuit-level gateway. This is the minimalist option. A circuit-level gateway doesn't inspect individual packets at all. It just verifies that the TCP handshake between two devices is legitimate. Once the connection is established, traffic flows freely without further inspection. It's fast and lightweight, but it's essentially saying, okay, the handshake looked normal, so everything after that must be fine. Which is like checking someone's invitation at the door and then letting them roam the building unsupervised for the rest of the night. Application-level gateway. Also called a proxy firewall. This is where things get serious. An application-level gateway sits between your network and the internet and creates a completely separate connection on each side. Your computer talks to the proxy talks to the internet. The two connections never touch each other directly. The firewall inspects all traffic at the application layer, meaning it can read the actual content of web requests, email messages, and file transfers. It can block specific websites, scan for malware inside downloads, and enforce security policies based on what the traffic actually is, not just where it's going. The downside? Speed. All that inspection creates latency, and some applications don't play well with proxies, causing compatibility headaches that make IT teams age 10 years overnight. Next Generation Firewall, NGFW. This is where most of the $5.4 billion is going. An NGFW combines everything above: packet filtering, stateful inspection, application-level awareness, and adds deep packet inspection, intrusion prevention, SSL decryption, and threat intelligence feeds into one device. It operates at layer 7 of the OSI model, which means it doesn't just see web traffic. It sees a user attempting to upload a confidential PDF to an unapproved AI tool. That level of granularity is the only way to manage modern networks. A traditional firewall sees port 443 traffic and says, "That's HTTPS, let it through." An NGFW opens the packet, identifies the specific application, checks the user's identity, scans for known threats, and then decides. The market leaders, Palo Alto Networks, Fortinet, Checkpoint, all build NGFWs with AI-powered threat detection that can identify and block attacks at machine speed. The trade-off is cost. NGFWs require serious hardware, constant updates, and expert configuration. Most people, including myself, think an improperly configured NGFW is barely better than a basic firewall. Web Application Firewall, WAF. This one doesn't protect your office network. It protects your website. A WAF sits in front of your web application and monitors all HTTP and HTTPS traffic coming in from the public internet. It specifically defends against attacks that target web apps: SQL injection, cross-site scripting, DDoS, cookie poisoning, and form manipulation. If you run an e-commerce site, a WAF is what stops someone from injecting malicious code into your checkout form and stealing every customer's credit card number. In 2026, AI-powered WAFs don't just match static patterns anymore. They learn what normal user behavior looks like and flag anything that doesn't match, like a bot submitting a form 1,000 times per second. Firewall as a Service, FWaaS. This is the cloud-native approach. Instead of a physical box sitting in your server room, FWaaS delivers firewall protection from the cloud. Your traffic routes through the provider's infrastructure, gets inspected, and then continues to its destination. The advantage is that it follows the user, not the location. An employee working from a coffee shop in Barcelona gets the same protection as someone sitting in the London headquarters. FWaaS is a core component of the SASE framework, which is the trendy acronym that means we moved all our security to the cloud. Quick question. Does your company still use a physical firewall appliance, or have you moved to cloud-based security? Drop it in the comments. Every database type explained is on the screen. Go watch it next.